Okay, so finally for question 6, your uncle, Mr. Tommy Jr. Horton, would like your advice on the optimal allocation of his portfolio between two mutual funds that have been presented to him by his investment advisor. They have determined that the following characteristics pertaining to these funds. Okay, so that's right here. Question 1. If the correlation between both funds were perfectly negative, what would be the characteristics of the least risky portfolio? So now we don't have, there's no explicit mention of short selling or borrowing constraints. So just keep that in mind. I mean, we can answer at least the standard deviation part of that question already. That's sigma equals 0. That's because if both assets have a correlation of -1, if they're both perfectly um, negatively correlated, then we have D and E. And if they're both perfectly negatively correlated, then we can find a portfolio kind of looks like this that has a variance of 0. Um, but anyway, standard way to do this, we just get formula for the minimum variance portfolio on the formula sheet. So we get something like square sigma E sigma D rho E. So as usual, this is equal to the covariance between the two. Sigma t square minus 2 sigma d sigma E rho. Right. Just replacing the values that are given to us, we found 60% in D, and we find 40% in E. So then we can calculate the expected return. So it's very straightforward. 60% times 50 times 12 is 40% times 17. And we should find 14%. And I mean, if we plug in the numbers into the variance formula, we'll also find that the variance would be equal to standard deviation would be equal to 0. So as usual, the calculation for that are in the spreadsheet. For the second question, your uncle wants to minimize the global riskiness of his portfolio. You explain to him that this is not optimal, but end up recommending the following allocation. So we end up recommending 23.4% in equities, 76.6% in bonds. Compute the characteristics of the portfolio. So nothing complicated here. We just replace the weights in the expected return and variance formulas, and we find 13.17% for the expected return, 18.67% for the standard deviation. For third exercise, for third question. For the remaining questions, suppose that correlation between the two funds is equal, so correlation between D and E is equal to 0.3. You convince your uncle to allocate his portfolio by taking into account mean and variance. His decisions will be guided by the utility function, blah, 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 quadratic utility function. His level of risk aversion is 8 equal 4. Determine the characteristic of his optimal portfolio. So, first step is to find the weights of the optimal portfolio using the optimal portfolio weight formula. So that's W of D is equal to expected return D minus expected return E plus A. But that's given to us in 4 minus that's and so we have A squared E squared minus 2 yeah, I think that's correct. And again, as usual, if we replace the value that are given to us in the formula, we will find weight of D equal to 63.3%. The weight of E, which is 1 minus weight of D, is equal to 36.70%. So then we can calculate the characteristics of the optimal portfolio. So we just calculate the expected return and standard deviation. If we do this, we'll find 13.84%, 19.11%. Okay, so now it gets a little bit more complicated. So I'm just gonna go to 4. Your uncle wants to include the possibility of borrowing and lending money to his portfolio optimization problem. Treasury bonds currently have a yield of 7% per year. So the risk-free rate is 7%. Also, your uncle can borrow money for investment purposes at a rate of 10% per year. So borrowing rate is 10%. What is the minimum level of risk aversion A over which investors would be willing to include treasury bonds in this portfolio? What is the maximum level of risk aversion A under which investors would be willing to borrow money to add leverage to their portfolio? What's your uncle's optimal allocation? What are the expected value and standard deviation of that portfolio? So it's a fairly big question. So we're just gonna untangle this by going in steps. Step 1. Okay. Just give me a second. So step 1, we can calculate both P1 and P2. So those are the tangency portfolio using the risk-free rate and the borrowing. Okay, so the force of formation here. Okay, so let's say the first step is to find the weights of the tangency portfolios. Okay, so for P1, for P1 we find WD is equal to 46.6%, weight of E 53.4%, expected return of P1 is 14.7%, and the standard deviation of P1 is 20.8%. Again, just want to remind you that all these calculations are in the spreadsheets that I've sent you. Same thing for P2, so we find weight of D is equal to 15.1%, weight of E is equal to 81.9%, expected return P2 is equal to 16.1%. Standard deviation of P2 is equal to 25.9%. So using those values, we can find both A-min and A-max. So A-min is equal to expected return of P1 minus RF sigma squared P1, and we find 1.77 max. And we find 0.91. All right. So since our risk aversion, what's the risk aversion? It's 4. So we have A equal 4. So it's greater than A min. So where our risk aversion is high enough that we want to invest in the risk-free rate. So I want to invest the risk-free asset. So the next step is to find the proportion to invest in that risky asset. So that's what proportion to invest in the risky portfolio. So proportion to invest in the risky portfolio, and that's so that would be the expected return on P1, because recall that we don't want to borrow, the risk rate is 7%. Equal to I think I'm missing something. Oh yeah, 8. So that's equal to 14.7% minus 7%, 4 times 20.8% squared, and we found 44.3%. So then we can find the expected return of the portfolio, so that's 10.4%, as well as the standard deviation of that portfolio, that's 9.2%. And recall that for this, to be able to calculate this, we need to calculate the weights to invest in D, E, as well as the risk-free assets. So on the risk-free asset, we want to put, that would be 1 minus Y star, so that's 55.7%. For D, that would be Y star times weight of D, let's say in P1. So that's 44.3% times 46.6%, and it gives us 20.6%. And similarly, we can find the same thing for E, and we find 23.7%. So using those 3 weights, we can calculate the expected return and the variance of the final portfolio. I'll do this last question. Okay. What is, I'm just going to put 5 here. What is the effect of adding the possibility of borrowing and lending in the portfolio optimization problem on your uncle's level of satisfaction? Explain why this level of satisfaction would be higher or lower. your uncle. So the investor doesn't want to borrow in the first place. So that's what we just found. Actually, his risk aversion is too high. Is too high to want to borrow. So he wants to, in fact, invest in the risk rate. So this has no impact on his optimal portfolio or even his satisfaction. Is there something else? Oh yeah. Your uncle's broker imposes a maximum margin of 50% in the value of the risky assets in his portfolio. What would be your uncle's optimal allocation and its characteristic? What is the effect on margin limit on your uncle's satisfaction? So again, this doesn't concern him. So it's basically the same weights as what we've just found before. And that's it for question 6.